Today we will demonstrate the different methods that can be used to separate mixtures. As you recall, mixtures are combinations of two or more things that retain their individual properties and can be separated by physical means. Some examples of mixtures are salads, dirt on the road, and even air. We will begin our experiment by mixing in 1 teaspoon of salt and 1 teaspoon of sand in a beaker of water. As you can see, the salt dissolves in the water, but the sand is insoluble. According to our definition, since the particles retain their properties, we have a mixture. We must also remember that particles can be separated by physical means, which brings us to our next procedure. The specific method of separation depends on the phase of the mixture. There are several types, including a solid in a solid in a liquid in a gas, a liquid in a liquid in a gas, or a gas in a gas. For our particular situation, we can use filtration since we can pass the mixture through a filter and collect the undissolved solid. Observe the process. The solution is passed through a filter to collect the solids that were not dissolved. Now that the process is finished, we can say that all the sand has been removed from the mixture. We have a problem when using this method. All filter paper has pores, and if the molecules we're trying to separate are smaller in size than the diameter of the pores in the paper, they will not be collected by this method. Since we still have the salt in the water, we should use a different method to separate the mixture. A common process used to separate a solute dissolved in a solvent is distillation. This process is an expensive way of simulating our water cycle. The water is heated to its evaporating point, then passed through a condenser tube that cools the vapor, which is collected in a container. Some countries that have very little freshwater resources have to use this process to get their freshwater supply. The method is expensive as it consumes large amounts of energy to heat the water to its evaporating point. Since we only wish to remove the salt, we will use an evaporating dish. The salt has been recrystallized and the water has evaporated. Now, let's look at a different situation. You spilled salt and pepper on the table. Your brother is allergic to pepper, and you need the salt. How would you separate them? Look what happens when you rub a piece of styrofoam on polyester cloth. As you can see, this electrostatic method can be used to separate the desired particles. The method is actually used in a variety of places. For example, some filters in air conditioning units use this method to attract dust particles. Also, rods are placed in smokestacks to attract particles from the smoke. We will now look into chromatography as a method of separating a mixture. For our purposes, chromatography is a process utilizing absorption of the components of a mixture in a porous substance. It involves two components or phases, a stationary phase or porous solid, and a mobile phase such as a liquid or a gas. Ink is one of the most common mixtures. You may have already seen separation of its ingredients if a leaking pen stained your clothes and you tried to wash it out. Its components are attracted to paper and water at different rates, so it provides the perfect demonstration of how the process works. Observe what happens. The paper acts as a wick, drawing the water out of the beaker. As the water goes up the paper and reaches the ink dissolves. A substance with low affinity for the paper and high affinity for water moves quickly up the paper with the water. A substance with high affinity for the paper and low affinity for the water moves slowly up the paper. This principle causes the ink components to separate. Now, complete your lab report.